Okay guys, we're gonna play with some Play-Doh here, and I am going to make a triangular prism. So you see how I'm gonna do this? I take my Play-Doh and I put it in here and I squeeze it through. And it makes a triangular prism. So we call this extrusion. I'll make this surface flat a little bit. And cut it off there, and I'll straighten it up a little bit. So you can see that it has the same cross section throughout, so if I slice this anywhere, it's going to be a triangle. And when you're thinking about what is the area of the base, try to think about this. Try to think about the Play-Doh pushing it out. So if we had a cylinder or a prism that had a hexagonal base, we can imagine it coming out like that, or a cylinder comes out with a circular base, or a rectangular prism has a rectangular base. So that's the extrusion. Now what I'm going to do, and this is an experiment so it may or may not work, but let's see how it works. If I calculate the volume of this. Okay, so let's measure. Let's see, I'll do centimeters. So 1 by 1.8. Get that down. So here's my triangle. 1.8. About 1.8. So I have that, and well, while I'm at it, I'll just measure what's the perpendicular distance. I could figure it out using the Pythagorean theorem, but might as well do it here. This is 1.7. Okay, so the area of my base would be 1.8 times 1.7, and it's a half of that, right? So half of the base times the height. And the volume of the prism is the area of the base times the height. So I would make sure the height is about 2.5. And I'll put it in the calculator. So 1 divided by 2 times 1.8 times 1.7 times 2.5. 3.83, and that would be centimeters cubed. Now I'm going to reshape this into a cube. Okay, so there's my cube. So measure this, I get 1.6, 1.7, and 1.6. So 1.6 times 1.6 times 1.7. And you get 4.3, is that approximately equal to 3.83? I guess approximately equal. This is not a exactness, but you get the idea that it's pretty close to the same volume. And there it is.